We have Dave Stokes joining us. Dave works on the MySQL team and is here to talk about JSON table and JSON validation, two new features to MySQL 8. Dave, please take it away.
Okay, thank you all for joining me today. These are two functions that you're going to only find in the open source world in MySQL, and for the document validation, I don't know of anyone else doing it as of yet. For those of you who don't know me, I'm Dave Stokes. I'm on the MySQL community team. You can find me fairly easily on Twitter at Stoker. Fairly easy to find on the other places like the forums.mysql or the mysql community.slack.com. If you have any questions, please burn them out. I'd rather answer your question as you have it than have you sit there and worry about not getting it in and have something go wrong. So let's get started. Of course, I work for Oracle, which means if I talk about anything in this presentation that isn't a released piece of software, this might be doing Q&A. Take it with a grain of salt. I do not have perfect knowledge of the future. And if I'm saying something's blue, you're thinking sky blue, I'm thinking royal blue, and it ends up being blue cheese. So let's do a quick peek at JSON. This is mainly for the old-time DBAs out there who haven't had to deal with JSON yet. According to Wikipedia, JSON is an open standards file format. It's become the way to interchange information between applications and servers over the past several years. Those of you who suffered through the XML wars and before the SGML wars, it's a lot easier to read, although you'll see some complications with that. There are actually two standards out there, ECMA 404, which I surely love that number, and the Internet Standard 90. You can read both of these in about 5 to 7 minutes. They're both very short, do not have a lot of details, very, very lightweight. And if you haven't seen JSON before, this is an example. This is a document, and documents have to be enclosed in parens. It's a bunch of key value pairs. If you have objects, they're enclosed in another set of parens. And if you have arrays, they're enclosed in square brackets. You can embed objects and arrays, arrays and objects, objects and objects, arrays and objects. You can get as messy as you want. The only caveat there is you have to unwrap it at some time. So if you're making it hyper complicated, you're hyper complicating your own life. Now, most relational database vendors now have a JSON data type or something similar. MySQL added theirs in 5.7, Oracle added theirs before that, and about the same time SQL Server was adding theirs. The caveat here is that the Postgres folks actually have two. And I know one of the Postgres committers was promising to turn in here, so this is kind of a joke for him. We're closer to their JSON-B implementation. Now, if you're an old DBA like I am, there's a lot of complaints about suddenly having all this stuff show up in JSON. There's no rigor, and we'll talk about how to get rid of that. Unstructured data does not usually work well with SQL functions. We'll talk about that. Messy. Yeah, it can get messy and cumbersome. And it's not the way that Edgar Cod wanted us to do stuff, which is probably the most valid. It breaks a lot of the rules of the relational model. But things have evolved away from that. So MySQL and JSON. Here's a simple example. I created a very overly simple table. Create table DBAMA1 has a column named doc of type JSON. Inserted that information you saw earlier, and there it is. Now, if I run a select command on that, it's out there. By the way, if you love idempotence, which means the thing comes back to you the same way you put it in the database, store it in a text type field. By the way, an embarrassing problem with my book is the text reviewers changed the word idempotence to impotence. So if you're reading my book and you're about the 3rd chapter and you see that, it's a good laugh at my expense, unfortunately. There is a function called JSON pretty, which will take your information and pretty print it. I highly recommend it. If you don't use this and you have old eyes like I do at 2 o'clock in the morning when you're trying to find something, it gets very hard and tiresome. So please use JSON pretty when you can. Okay, JSON table. This is a function you'll find in a lot of the databases out there. In the open source world, the only two databases that are missing it right now are ironically Postgres and Maria. JSON table is designed to turn your unstructured data into a structured table temporarily. You're not permanently doing it. You're just basically taking your JSON data and casting it into a SQL table. Now, here's the syntax. As you can see, this is as lovely as all the syntax is for MySQL. If you're going through our documentation, I think it's a little bit lacking. That's why I ended up writing my book. This helps you, but you kind of have to know what you're doing, and finding good examples is getting easier. But 2.5 years ago when I started the book, it was very hard to find examples. So let's look at a simple example. Here we're going to select a star from JSON table, and you see the arguments in there. Well, what is all those arguments, Dave? Well, the first one is either the document or the column that we're going to feed into JSON table. And in this case, it's the object. Well, it's a document with a key of A with a value of B. And the $ represents the entire document path. This is the entire document. If you see the line below $.a, that's anything on the document path starting with A. Now, we do have an alias in here, which I'm just showing that you can have an alias. It doesn't do anything in this example, but it is out there. Now, this line here, it's often better to read this from right to left. What it's saying here is the stuff in purple, $A, anything that matches that pattern, any key that starts with A, we're going to take that and we're going to cast it to a text field, and we're going to call it foo. Slightly more complex example here. The data is up at the top, and what we're doing is we're using JSON table for a column named doc, and we're going to take anything that's in an array. That's the $, square brackets, asterisk, right bracket. And we're going to say, okay, anytime, reading this from right to left, let me see if I turn my mouse to a pointer. Anything we have on the document path that starts with an X, we're going to cast as an integer and call it X value. Anything that starts with a Y, we're going to cast as an int and call it Y value. So up here we have X and Y of 2 and 8 respectively. Next one is 3 and 7. Last one is 4 and 6. Once again, doc is the column that we're using. We're pulling it from a table called DBAMA2. As you can see, I'm rather creative on the table names. Once again, $ asterisk by square brackets is the entire array in that document. Now, here's something that's kind of handy. We actually can add row numbers for ordinality. This is the same information, but this time, every time we run into an array, it's going to increment this. So we have row 1, 2, and 3. Nested paths, as I mentioned earlier, you can nest stuff within other stuff, and it can get very, very messy. This is an example that we're going to go out and we're going to find anything that starts with A. So up here we have an A, up here we have an A, and in magenta here we have an A. And we're going to look for a nested path for an array that has the key of B. And we're going to take everything in that array and we're going to cast it as an integer and call it B. Now, this can be as complex and as easy as you want it, or as nasty as you want to be, but it is easy. Parsing this stuff in some languages like JavaScript gets really nasty, but this is a handy way to do it. By the way, note down here I have where B is not null. This is an example of throwing stuff off to SQL for some processing. So if we look at our information here, we have, this is an example of using a default value. So if we come here and the value for $A is empty, we're going to push the value of X being 333. and call it AJ. And if we come down here, we see that our third entry up there, there is no A. Up here, there's no A. So it plugs in the default value for us when there's no value of A for us. Now, something similar is that on an error, we're going to, in this case, put in the value of 999. And the default value in this case is going to be 111. And we're going to take anything on $A and toss it into a column called AC. Now, if you look at the third example up here, A is 0. It's not an array. So it takes our value from the default that we have here. And in the second or the third example we have here, there is no A. So it figures out that we need to put the default value of 999 when there's an error. In this case, it can't cast this value as a varchar. Have I lost anyone yet?
Well,
no, it'll make sense to me.
I guess the question I'm asking myself is, why would you want to do this?
When you get a lot of statistical data, there's always missing data, and rather than throw a null in there, they'll leave it empty or they'll leave it blank. The old COBOL days, we used to put in values like 999 to signal that it was bad, which worked great unless the actual value was 999.
Right.
But also I'd like to mention something that just added in 8020. You now have to have default on empty before default on error. We had it before 820 where you could have it the other way around, where default on error could come before default on empty. But the standard says it has to be default on empty first and then default on error. Something else exists. If there's a, in this case, anything that starts with B, if it exists on the path, we're going to cast that value as an integer. And I don't know, I have this highlighted, but here we have B has the value of 1. And it casts that into our value. Now, none of the other ones up here have a B. So we have been able to say, okay, if this piece of data exists, this is what we're going to call it. Once again, it's handy for when you have missing values or incomplete data.
Question, we don't have a Boolean for, or better, how do we cast a Boolean from JSON to SQL in this case? Because the BX should be a Boolean rather than integer.
Yeah, it should be, but it wants to treat everything as an integer. I don't believe the JSON standard has, I have to go back and read that. I don't think it has true Booleans.
It does.
It does. I'll have to go out and play on that, and let me see if I can find something, and I'll write a blog on it and make sure you know about it.
Good.
MySQL doesn't have true Booleans. That's another kind of nuance.
Yeah.
We know that.
Here's an example. Fred and I have been showing this one a lot. Basically taking a lot of information from JSON table and feeding that to a CTE, and then feeding that CTE data into a windowing function. Can't do this with Mongo. So if you need to do a lot of complex analysis, a lot of stuff we used to use SPSS and SAS for, you can actually do that from JSON stuff all from within MySQL without having to feed it off to another application. And that, believe it or not, is the 10-minute overview of JSON table. There's a lot more out there, a lot of more interesting functionality, but that's 80% of the functions that you're going to use. Now, document validation is, I think it's something that we're going to end up using a lot of in the future, as I talk to various data scientists. The idea came from the JSONschema.org folks. They're trying to get their work adopted by the IETF. The basic idea is that you, by default don't have a way to have rigor on your data. If I write the information to a JSON document as email, and I keep it all lowercase E-M-A-I-L, Morgan's doing it as E, uppercase M-A-I-L, Liz is doing it as electronic dash mail. There's no rigor to make sure that things are actually there the way we want. So there's a function called JSON schema valid, which returns a one if the document passes the exemplar schema. On the left is our exemplar. We're going to say we're going to have a object, and the properties of that object is that it's going to be called my age. It's going to be numeric data, and we're going to have a minimum age of 18 and a maximum age of 99. And on the right, you see that we create a small document, my age 33, and then we run it through JSON schema valid. The exemplar first, the document second, and of course it matches and you get the one. Now, with constraint checks, which came in the last year, we can actually plug this in where we're going to have a constraint. By the way, I really recommend naming your constraints. Otherwise, it says constraint 1, constraint 2, failed, constraint 3. It's a lot easier to find if you actually have named your constraint. Once again, with JSON schema valid, my age, the type, minimum this case is 28, maximum 29, and we put in here required. So if you try to put in this document into the database and there's nothing in that document with my age, it will reject it for you. It's a lot easier to keep out bad data than to fix bad data after it gets into your database. So in this case, we're going to come in and try to put in someone who's below the limit. And we get the constraint message that my age and range failed. Put in someone who's 97, one row affected. You can use this for all sorts of data types, ranges, and create required fields in your documents before it gets to your instance. Let's see. Something that gives you a little more detail is you can run JSON schema validation report, which gives you a little more detail. This is something from the manual, and you see it's not much more data, but it's a little more data. By the way, I want to mention my book. It's getting a little long in the tooth, and I am trying to start working on the second edition. Amazon has sales on it all the time. So instead of making 3.5 cents, I make 2 3/4 cents per copy. Woo! And with that, I'd like to go into the Q&A and see what questions you have. I want to keep this a little short and sweet just in case.
Sure, I might start. Maybe it's a leading question, but JSON table, it's a table function. I wonder if you can talk a little bit more about that, because it's different from other functions.
Well, other functions are either setting, getting, or giving you metadata about the information. This is a way to cast data. That's the only way to do it. What do you think of when you say table function, Morgan?
So it returns a result set rather than it returns a scalar value. And there's other table functions that are possible. So JSON table is in the standard, but in other databases like Postgres, you can generate a series of values with a table function.
Kind of like a sequence, or?
Yeah, you can do a sequence with a generate series table function.
Yeah, I was reading through the stuff last week on Postgres's implementation of JSON table. They're slowly limping along, getting there. They're working on a lot of the, last I saw, the if exists functionality, which I guess is tougher for them than it is for our engineers.
So I have a question that is follow up on Morgan's question. Can you use this table in a join, or can you convert that table into a real table?
You mean like a materialized view, or?
Yes, I mean something that I have in a JSON big document. I want to convert into a JSON table, and then I want this to become a stable table?
You can use it with other SQL functions. Let me go way back up here. The easiest one. Oh, thought it was here. And of course, I went way past it. As long as you can get it out of the JSON table, you can anything from this you can use in the where clause. You can also reference the various elements up here on the select line. So we could have done a select JT, JT.A or whatever. Making it into a materialized view, I could see somehow using a regular view, but it wouldn't actually be materialized. I know folks who run this function on data sets and put it into temp tables and then do other analysis on it, but it's not for making materialized views.
But of course, I can do a insert into table select star from.
Yeah.
Okay.
They do become like regular MySQL values. It's that column expression that's saying how it maps. So then it is like a MySQL table.
You can materialize it yourself, essentially. Just create a copy of the table.
Yeah.
And can you make changes into the data with the same flexibility, or are you just selecting out of it?
The JSON table is just selecting out of it. It's once you get it out of there, you can run other regular expressions or conversion functions.
Right.
I have a feature request there that's missing. So
Okay.
I would love to be able to do an update statement, an update into part of a JSON document using the shorthand JSON expression of the, dash greater than.
Okay. Send that to me in an email. I'll get it out there to them.
All right. So I think it's close to that, but it's not perfect for the kind of updating partial JSON in a natural way.
Well, the other problem is the standards committee changes their minds every so often on stuff, or as they implement it, they came back with changes. So I can propose it to our engineers and then see what the standards committee says. Not that the standard committee listens to me.
I have a question about importing. Long time ago, I did some experiments into importing from MongoDB to MySQL document store.
Mm-hmm.
And when I tried that, I saw that the JSON generated by MongoDB has several functions that are not standard JSON.
Yes.
Meaning that you know what I'm talking about.
Yeah.
So
Yeah.
can I deal with this kind of let's say irregularities using the syntax for JSON table?
Not from JSON table. However, the shell has a bulk loader that knows how to handle a lot of the various BSON irregularities for date, time, and other things out there. And that will bulk load in parallel. I think it goes up to 5 or 6 threads at a time. And that has the logic built into it to be able to convert stuff over like their date strings.
So without the shell, I cannot. I mean, the doctor told me to stay away from the MySQL shell.
Well, I will report to the engineers that Giuseppe is allergic to the MySQL shell. No, the funny thing about the shell is Fred and I have been doing a lot of testing on some other functionality for the shell for in terms of uploading and saving data. And there's a lot of engineering effort going in there. So the shell is just going to keep getting smarter and better. It's one of the things where the database functionality has a certain set of things it has to do correctly, and keep trying to tack on things like that onto the server is just messy. However, the shell is kind of wide open for us. So a lot of the interesting things in the uploading world are going to be there.
This may be a very general question, but for sure, like coming into this, I didn't really know what to expect. I don't really know like what people use this for necessarily. Can you maybe talk a little bit about like common use cases here? And
well, since we're all technically old DBAs, and we're used to having things normalized the way COD and God wanted it to do it.
Yeah, hey, speak for yourself.
Okay, Morgan has the exception there. Suddenly people started wanting to put JSON data in their database, and throwing in a text field had limited functionality. So everyone started adding JSON data types and functions to manipulate and get data back from that. Imagine you have a Internet of Things device like a camera by your mailbox, and today it's telling you the temperature and time. There's a new firmware that comes out tomorrow, and it's giving barometric pressure. Well, do I really want to run an alter table to get that barometric pressure in there and change my upgrade scripts and everything else, or my import scripts? It's easier just to throw everything into that 1 gigabyte blank tablet out there and just dump it all in there in JSON format. And if you need to tease it out permanently, you can use a generated column. If you want to do it temporarily, you can use JSON table. But the idea is we have so much stuff spewing out JSON, it's easier just to save it as JSON. What's also interesting is a lot of folks have stuff that's not in JSON that we have functions to move it over into JSON temporarily. So it's kind of a grab bag. Now, side effect of this is in cases where you have things that are changing, like the barometric pressure, you don't have to go out and restructure your table every time there's a new firmware upgrade. So where things are changing rapidly, it's handy. The other thing is it's kind of nice in places where you have a lot of what I call change stub tables. You get someone's customer number, and then you go back through the orders, and then the last order, suborder, and then the shipping information. So you're going index table, index table, index table, index table to figure out that they finally ordered a blue tablecloth. Well, rather than have all those nasty joins or a bunch of nasty many-to-many relationships, throw it in a JSON table. In a lot of cases, it's a lot faster to read.
Right. So ultimately, it's just kind of, it's accepting that we're going to be delivered a set of unstructured data on the regular, and we want to store it in MySQL to make it easier to interact with, and maybe store it in a structured way down the line. But it's okay.
And one of the more popular programming communities has been taught that database joins are evil, so you want to have everything in one big flat table. So.
Got it.
Yeah, I would also argue another element, which is even though we love to normalize, sometimes when your source format is like a standard, you actually lose data where you kind of convert from that source.
Yeah.
So if you keep it in the same format, essentially with JSON, then you're not losing information. And then you can kind of, with this, provide indexing on top of it and other stuff.
Yeah. One of the banes of my existence early on in my career was I was working at a university and getting 2 sets of data, big loads once a year. And one source had year as 2 digits. The other one had it as 4 digits. And every year they suddenly changed their information, and the programs to read in the information were all in Fortran. So Fortran formatting is always a nasty thing to deal with. So I'd have these 2 sets of data, and I'd have to reconcile them and then run it through another package that we had written internally and change that and say, okay, last year we used 2-digit years, this year we're going to use 4-digit years, and all that sort of stuff. So in that case, I could have read them both in hopefully in JSON, hopefully they're putting it in JSON. Didn't matter the data type. As I read it out, I can say, oh, this is a 2-digit year. I can change this on the fly. Oh, this is a 4-digit year. I can change that on the fly. So hopefully less data manipulation.
Yeah, if I can share an example of what I meant by the previous comment, I was browsing a real estate website, and I noticed that it was returning from its API in JSON. So I just wrote a Grease Monkey script to save that to my database, and I didn't know which fields I wanted yet. But because that was the native format, it was just very easy to dump it. And then progressively, I would write queries on that to try and find stuff I liked based on certain attributes. I know it's very geeky, but
That's the most DBA thing I've ever heard.
Yeah. I could use another API to calculate distance from where I am and driving distance, stuff like that. It's really nice when you don't have to think ahead of time.
Sure, yeah.
Well, for instance, there's a company near me that runs a multimodal transport center, which means they're getting things off airplanes, trucks, and trains. And the various shipping companies have various things that get spewed out from their RFID tag. So if you're wondering, where's that stuff I ordered off Amazon, they can actually track through, and they have various readers all over the country and outside the airport. So as the semi-truck goes by, it tries to read all these tags. And stuff's updating, and if you're shipping with one company A and then it gets transshipped on company B, it kind of gets crazy. And they'd rather just get the raw data and throw it in there and then parse everything out themselves. So
cool.
Makes sense.
Yeah.
Thanks.
So I have another question. Is the lazy people question?
My favorite.
Yes. So let's assume that I have data that is already, let's say, standardized. For example, if you get the list of releases from GitHub API, you get data that is more or less always the same. So you have a bunch of records that have the same fields.
Yes.
Is there a way to import this kind of data automatically without specifying which columns I want and which type they have? So can JSON table figure out the contents, the schema from the contents?
As long as you have it in key values, you should be able to tease things out.
Yeah, but do I have to write all the columns like in your example in the screen? No, I don't want to do that. I mean, I say that is the lazy question.
You want JSON table select star, right?
Yes, exactly that.
Yeah,
I want to convert that JSON data into a table.
Yeah, unfortunately, I don't know of a way of doing that. I'm sure the standards committee for that would love to figure out a way to do that and make that
No, don't tell me that the shell does it.
The shell doesn't do it as far as I know.
Good.
But then that might be something the engineers are working on. You'll find out about that in 2 months when the next release comes out.
Yeah, I think you kind of teased it, but both of these functions, JSON table and validation, are part of the SQL standard. So MySQL could extend it, but I don't know if it is in the standard. Be interesting to check that.
And once we do extend it, we get jumped on yet again for not following the standard. So
it mostly only becomes problematic if the standard implements it, and then you discover you've implemented it differently, and then you have to reconcile. That's the toughest case. And that happened with JSON because every database implemented it before the standard was ratified.
Yeah. Well, I'm hoping the JSON schema folks get their stuff ratified by the IETF, and I hope we did it the right way. But it's a good use for it.
We will see. We will see.
Yeah.
Okay. Any further questions? Dave, if you don't mind holding on for 5 minutes after we turn the video off, maybe we can answer further questions there.
Okay.
But going once, going twice. Okay, I'm going to stop the recording. Dave, thank you very much for joining us today.
Well, thank you for having me.
Inviting us to JSON Features.
So now we can ask the nasty questions.